Soil moisture and weather monitoring brought to you by MEA and Green Brain. How do you know when it's time to fuel up your tractor? You check the fuel gauge. How do you know you've put the right amount of chemical in your spray tank? You measure it. How do you know your irrigations are meeting your crop's water requirement? How do you know when to irrigate your crop? How effective was that rainfall event? Was that last irrigation shift long enough? Where in the profile is the crop extracting moisture from? The data shown here is from a dryland barley crop. We are looking at 1 month of data in a stacked graph. The stacked graph shows soil moisture levels from the top to the bottom of the probe. In this example, from 10 centimetres down to 80 centimetres. We can see by the flat lining here that the crop has extracted all the moisture it can out of the top 30 centimetres. Stepping or daily crop water use is visible here at 40 and 50 centimetres and a little bit at 60 centimetres. We can see the stepping starting to decrease here at 40 centimetres as moisture runs out at that depth, but the crop continues to search down through the profile at 50 and 60 centimetres, chasing that moisture. In an irrigated system, the crop typically wouldn't be pushed this hard. We can also see what impact rainfall has had. 2 events, the second one being a 9mm event, only having an impact to a depth of 10 centimetres. In this example, we're looking at data from a tree crop. On the left, we can see the crop is using moisture from the top 40 centimetres of the profile, where the active root system is. We can also see the impact from irrigations. The ones circled here have only had an impact to a depth of 10 centimetres. These irrigation events have had an impact to a depth of 30 centimetres, but this still hasn't been enough to replace the moisture that was used by the crop at 40 centimetres. Here we have an average graph of the data from the previous slide. We've created an average of the top 30 centimetres of the profile where the bulk of the root activity was taking place. Even consistent stepping indicates the crop isn't having any issues extracting water. Smaller steps and flattening out of the line indicates that the crop is struggling to access moisture. The average graph is also where we can set our refill and full points. The aim then is to maintain soil moisture levels between these 2 lines. Once refill and full values have been set for each site, they are listed here on the soil moisture overview. Sites are prioritised from driest to wettest. In this example, the first 4 sites are below refill point, needing irrigation. Site Block 4 Shepherd is between the refill and full point. The orange section is the bottom 20% of that range, and the green is the top 80% of the range. The water droplet icon indicates where moisture levels are within that range. Block 2 Shepherd has recently been irrigated and moisture levels are above full point. How much to apply? The data shown here is from an avocado crop being grown in a sandy loam soil. We can see the impact of a 70mm rainfall event, with moisture working its way down through the profile to at least 80 centimetres. We can also see, following that event, where in the profile the crop is drawing moisture from. Irrigations are kept short and frequent to maintain moisture levels in the crop's active root zone. We can see the effect of an 8mm rainfall event here, with moisture levels increasing to a depth of 20 centimetres. The data shown here is from a macadamia crop. Stepping is clearly visible in the top 40 to 50 centimetres of the profile. Every irrigation is having an impact down to at least 80 centimetres beyond the crop's active root zone. This is wasting water, wasting energy to pump the water, and potentially wasting fertiliser as it is being leached beyond where the crop can easily access it. We can also see here where the stepping has tightened up prior to this irrigation. This would suggest that this irrigation could have occurred a day or 2 earlier. To overcome the impact at depth, the runtime of each irrigation event should be shortened. Data shown in this example is displayed in an individual graph. Soil moisture content data is displayed in relation to the left-hand y-axis. Sometimes the data can become difficult to read as data from the various depths is overlaid. Here we have the same data but displayed as a stacked graph. It can be easier to see where the crop is extracting water from, when it's running out, what impact the irrigation and rainfall have. Here we can see 2 irrigation events, both 2 hours, 1 day apart, and what impact they had. The first irrigation had an impact down to 40 centimetres, the second down to a depth of 50 centimetres. We can see that the crop was drawing water from the top 30 to 40 centimetres of the profile. These irrigations were getting water to where it was needed, but not much further. The next irrigation ran for 6 hours. This had an impact to at least 80 centimetres, well below the crop's active root zone. Also, note how quickly soil moisture levels dropped following the 6-hour irrigation event compared to previous shorter irrigations. Here we have the same data displayed in an average graph, an average of the top 30 centimetres. See how the soil moisture level drops rapidly following the 6-hour irrigation. This indicates that the soil has become saturated and water is draining through the profile. Note the similar sized steps when the soil moisture levels are within the refill to full range. See how the stepping starts where the full point has been set. This data is from a young avocado crop during a hot, dry summer. In late January, we can see the crop actively using water. Why the sudden decrease in water use in February? Did conditions become cooler and overcast? No, in this case the trees were pruned in early February, which reduced the amount of water use. Would the grower have known how much to adjust irrigation by after pruning without having a probe in the ground? If he didn't adjust his irrigation schedule, the crop could have become waterlogged and increased the risk of disease such as Phytophthora. This data is from a probe that can measure soil EC, or salinity levels. Here we can see how EC levels trend over time, with levels increasing up until early October. We can then see if or how far these salts or fertiliser are leached after rainfall or irrigation. These are just a few examples of using GreenBrain to schedule irrigation. It is an ongoing process that can be continually refined, and MEA suggests working with your MEA agent or agronomist to get the most out of your system.